General Introduction to the CBA or Cost Benefit Analysis tool. The Cost Benefit Analysis or CBA tool has been designed for European public clients with varying degrees of knowledge and experience of BIM, Building Information Modeling, enabling them to evaluate the adoption of BIM in their projects with maximum clarity. This video will guide you through the steps required to calculate the costs and benefits of adopting BIM in public tenders. The CBA tool includes four main sheets: the input sheet, the results sheet, and the CBA sheets. On each sheet, you can find explanations and guidelines by clicking on the information symbol. The input sheet collects the preliminary information on the public organisation, the project, and the features characterising the asset. Once the input sheet is completed with all the required information, the results sheet can be consulted, where you can consider results for both BIM maturity levels 1 and 2. A more detailed insight on the results can be found in the CBA sheets for each BIM maturity level. When you have completed the analysis, you can reset all the sheets by clicking here. Input. First section. Preliminary General Information. Let's have a look at the first section called Preliminary General Information. In the first question, select whether the organisation involved in a construction project has prior experience with BIM, or if the project under study is the first time using BIM. Depending on the selection, either question 1.2 or 1.3 needs to be completed with the average number of projects in which BIM is or might be actively used every year. Let's assume our organisation has no prior experience with BIM and that BIM might be actively employed in 15 projects in a year. The project refers to a new residential building construction project. So here we select New Asset Construction. Following this selection, question 2.2 becomes inactive. Let's assume that our project requires an investment for planning and design of about €69,000 and a foreseen construction cost of about €2.2 million. This information should be entered in questions 3.1 and 3.2. The following questions require us to select the number of years, as close as possible to the actual time necessary for the construction stage of the project, and the number of years necessary to carry out the project planning and design activities. Let's assume our project requires 1 year for the completion of the construction stage and 1 year for the planning and design phase. The next question, either 5.1 or 5.2, depending on what has been selected on the question regarding prior experience with BIM, requires us to estimate the number of employees in our organisation who will be directly affected by BIM introduction, especially referring to the use of new software or the need to attend ad hoc training sessions on BIM. In this case, we expect that BIM introduction in the organisation will directly affect about 39 employees, considering those from the technical and procurement departments, project managers, and administrative office personnel. We insert this figure in question 5.2. Because our project refers to a building, we indicate the gross floor area of the asset, corresponding to about 1,800 square meters. This information can be entered here in question number 6. Question 7 asks us to provide an annual cost for the asset maintenance. We could leave this space blank, as this question is not mandatory, but we do expect that the annual cost will be close to €30,000. Next, in question 8, we select whether the BIM coordination is performed internally or externally. We select the latter option, as our organisation has no prior experience with BIM. In question 9, we provide the average salary of the employees in our organisation. In question 10, we indicate that we expect to use a common data environment in the project as required by tender documents. Finally, we also indicate the inflation rate we want to consider during the project period. Second section, BIM Model Creation Information. The second section, called BIM Model Creation Information, firstly requires us to indicate the level of detail of the model required in the tender. We select one corresponding to basic design. Next, in question number 13, we indicate that the project relates to a building, selecting option number 2. Lastly, we indicate the average national hourly cost for a BIM specialist that is charged to public clients. In this case, we enter €25 per hour. The next sections to complete will depend on our selection in question 13. Having selected buildings in question 13, we next complete the architecture and structure and MEP design. Third section, architecture and structure. Firstly, in architecture and structure, we need to consider the surfaces of our project asset which need to be modelled. We select whether there are areas and/or rooms in the asset with a surface that is included among the set of proposed surface sizes. In particular, we counted that the asset comprises about 125 rooms whose surface is smaller than 25 square meters. So we select yes, then consider the rooms belonging to this range as being, on average, moderately complex as it involves some details needing to be modelled. Therefore, we select 2 as the level of complexity. Lastly, we select 125 here. With the same logic, we counted the areas belonging to the other surface size ranges, and we also add 4 areas with a surface comprised between 150 and 300 square meters, representing the building facades, and an area with a surface larger than 300 square meters corresponding to the roof. All these surfaces, we believe, are relatively easy to be modelled. To complete this section, we finally select the average level of standardization of the asset areas, following the guidelines appearing in the pop-up window. This is a rough indication about the extent to which, for example, after modelling one of the 125 areas with a surface area below 25 square meters, this area can be used as a basis for modelling the subsequent ones. For example, let's assume that our asset is composed of a set of standard housing units which are very similar to each other. So we select a standardization level of 3. Fourth section, MEP System. Having selected buildings in question 13, we also have to complete the MEP design section. Here, we indicate whether our asset comprises the list of systems proposed in this interface, in particular, mechanical system, piping system, electrical and lighting system, and special systems. In this case, we start by indicating yes for the mechanical system and, with an approach similar to the one adopted in the previous section, we evaluate the level of complexity of each system. In this case, we believe the system is not very complex, so we select 1. Lastly, for each system, we must consider the surface area of the building served by the system. In our case, this system is estimated to occupy an area of about 1,200 square meters, so we select option number 2. The same logic applies to the other systems. Output. Results page. The results page provides an overview of the indicators computed by this tool. In particular, the same set of indicators reflecting 2 different levels of maturity for BIM adoption are provided here: Maturity Level 1 and Maturity Level 2. The values of indicators provided are estimates calculated from our inputs and combined with the information contained in 2 underlying databases. The tool incorporates an option which adjusts the output based on variations of 8 critical variables. 4 of these underlying variables are related to the costs associated with BIM adoption, and 4 are connected to its benefits. In this sense, Here we can select the scenario we would like to consider, the baseline one, the pessimistic, or the optimistic ones. The main indicators proposed in this page are the following: the benefit cost ratio and the net present value. Two versions of these indicators are reported, either including or excluding social and environmental benefits. A short definition for each indicator is provided by clicking on the information symbol. In addition, the direct costs generally associated with BIM adoption in the project are calculated and reported here. The same indicators described before are also computed for each of the three phases of a project considered by the tool: the planning and design phase, the construction phase, and the operation and maintenance phase. In this case, the overall project benefit cost ratio is higher than 1, and the associated net present value is positive. In this sense, the adoption of BIM in this case study is expected to be advantageous and sustainable. The layout of results for BIM Maturity Level 2 mirrors the BIM Maturity Level 1 results. To understand how the indicators and the values reported in this page have been obtained, it might be useful to check the pages dedicated to the cost benefit analysis. CBA page. Let's start our overview of the cost benefit analysis page by highlighting that the tool proposes 8 benefits, briefly described here, and 9 costs, indicated here. These costs and benefits are allocated based on our input over 3 project phases: planning and design, construction, and operation and maintenance. At the top left of this page, it's possible to select the phase we'd like to focus on, but let's select all phases so we can view the entire page. Here, the inflation rate applied to the cost benefit analysis indicated in the input page is reported. For each cost and benefit, you can select whether the indicator must be included or excluded from the analysis. Let's assume that our organization does not need any investment in hardware upgrades, as we believe our current equipment already enables the proper adoption of BIM in the project. In this case, we select Off. Some lines are dedicated to computing each year's total benefits and costs and their difference. An ad hoc cash flow is generated in this line, and this enables the computation of the indicators we have seen in the results page. Here, we can modify the discount rate to be applied to the computation of the indicators. Let's assume 4%, the default value, is suitable for our project. We can see that the only cells whose value can be modified are white. Lastly, a section is specifically dedicated to the computation of the economic net present value and the economic benefit cost ratio for each of the 3 phases separately. The last 3 tables are necessary for computing the indicators of the results page, which exclude the environmental and social benefits from their computation.